panel discussion on AI, ML, edge computing. And we have some of the very interesting folks from the industry um, part of this panel. I would like to request IVK, CTO of Cryon Data, is going to be the chair.
Sure.
Daniela Pau, ST Microelectronics. Amit Gupta, CTO, Enron Energy. Lux Rao, Dimension Data, Director. Chetan Kumar S., CEO and co-founder of Icon Labs. Can we have all of them on the dash, please? You can sit anyway. No placards. Can we get one more chair? No, I think it's fine. So, IBK, you have the floor. You can sit down.
Good afternoon. My name is Vijay Kumar Iveturi, IVK in short, and I'll be moderating this panel on Edge AI ML, one of the hottest topics. Before I start, when this topic was given to me, it reminds me of a very famous battle in World War II called Battle of Midway. It's a decisive battle which the Allied forces won, which turned the war in their favor. In my view, the Battle of Edge is also like the Battle of Midway. The interesting part is that in the Midway battle, or the Battle of Midway it is called, in Pacific, the naval forces of Japan and the tanks of Germans are much more superior to the American and British and French forces. It might surprise many of you now that they are actually superior, but the reason they won that battle, actually both in Europe on tank battle and also the battle in the sea, supposed to be one of the fiercest and the most popular battles ever won, because they had better intelligence. Very surprising, isn't it? So it's not the equipment, but the intelligence on it. As a keen tracker of military history, there are many such battles, and you'll be surprised to know that when you apply it in Indian context, I have to say that more than 95% of the forts which fell to the conquering Mughals or the British, they were opened from inside. Surprising, right? Somebody had an insight that somebody happened to be Babur, or the British later, that in India, they work for the person who pays. So if you pay the right person, the door will be opened. So sometimes insight and analytics, make you win battles and perhaps countries. And we don't know whether that is the case here. So let me give some context of how I see edge computing key issues before I invite my panel of experts here to share their views. To start with, for those of you who worked in early 90s, especially if you come from communication industry like me, there were two famous battles, right? One is voice on TDM, and then the IP switching, which is packet. They always fought for the architectures and standards. The point is voice is regulated, and you have to comply with the standard, both for its compression and network, including toll quality, like finance, whereas data packets are not so at that level. So for those of you who are familiar with that, would also remember the famous architecture battles in computer science, also called client server, or the famous 3-tier architecture. We can add one more tier later, but those were the days. I think we are back to the same equation now, Is it another fad for edge computing to have a three-tier architecture driven by essentially, well, the same, the network vendors and the cloud vendors, the people who come from computing and the people who come from networks? They seem to have a different points of view. I think that's one of the issues to debate. The second one, do we have to run analytics on edge? So there is a very famous theory or a famous statement that we need smart endpoints and smart cloud, but dumb pipes. And somebody else said, no, we need a very thin endpoint or light endpoints, but smart pipes. Well, if you have ever programmed in the late 90s and early 2000s, this is precisely the debate for middleware in computer science. For those of you who remember EJB, this was exactly the heavy mid-tier. Are we going back to the same architecture model? Something to think through. Third one, should we challenge the signal processing on edge and analytics on cloud? This is the typical mindset for many people who work in this area. Run the signal processing on the edge, your discrete cosine transform or fast Fourier, but do the analytics, which are your famous regression, cluster, k-means, whatever, on the cloud. Really? Then why do you run AI ML on edge, and why should we? So if I come from the cloud angle, I want to do everything on the cloud and do the minimum on the edge. Signal processing for latency, maybe yes. In other words, the media processing seems to be on the edge, while the analytics at aggregate level is viewed like another data pipeline or data lake on cloud on which you curate and run. Is that so? We should debate that. But if we for the moment agree that we run the AI ML loads for the analytics, here comes the question of the systems. Do we need specific chips? Do we need specific hardware to support it? Can the same hardware support a signal processing load and AI ML load? Are you saying that I can run a fast Fourier or a Kalman filtering, which is required for image processing, in the same way I do logistic regression? Should it work? I think that's an interesting question on the firmware level and chip level, board level architectures. Incidentally, we had the same debates when we did voice processing, just to give you a bit of history. In fact, I remember in late 80s, we used to argue that if you compress voice a little more than required, then you cannot have a real-time storage because our drives were not so fast. And hence, it will stop at a certain level. Today, we compress much more, right? And if you are from creative arts, you will never like any digitized voice, right? At the end of the day, you appreciate what is analog, not digital. Now, if our edge ML solutions, topology aware, this is a very famous question coming from network side. If I'm running on edge, or if I'm running, am I supposed to be aware of the topology of the sensor network? If you use there is a sensor network, wireless sensor network or software-defined WAN in that sense, or WSN. So should we worry about ad hoc versus mesh versus topologies? Should I be worried if I'm running that on edge as a software developer or even as a system designer? Then we come to the packaging part, which is a very important debate if you're raising money, raising funds. Should we run it on custom hardware or should we run it on COTS hardware? Again, a famous debate. If you come from the communication background, the original switches were all designed for custom hardware before it moved to COTS, right? In fact, even the software programming languages were proprietary. But they all moved to more or less commoditized. Will that happen here? And as a venture capital person or as an angel investor, if I have to look at it, just to give you that perspective, should they invest in edge AI ML startups? In other words, one thing they always get a shock when you pitch to them is that they have to fund the inventory because they have to fund the boards, if you have boards. They just want the software, so it's not a SaaS model. So why am I taking money on which 60% of my money goes to someone's inventory? It doesn't, what you call, bend the growth curve. These are the questions an investor asks. And coming from a business angle, from a corporate angle, or even from a startup angle, is there an ROI for all this? Or is it just a hype? Do corporates get any ROI by working with an edge AI ML startup? Nobody knows. Maybe we have answers. Let's ask the panelists. Then the last one, which is a popular debate nowadays, independent of which panel I run, are we being watched by machines? There is a theory or a principle in psychology that you get less offended when a machine stops you than a person. However, you buy a ticket when a person asks you to buy and not a bot. Surprising, right? Change of context. So if all machine data is stored, aggregated, moved across, it has other metadata. I can derive a lot about the user, just like your hotel rooms. The sensor is there to see how much of air conditioning should be there or should be switched off. But if I do an aggregate analysis or timeline series on it, I can figure out when you are in, when you're out, what you ate, perhaps a lot about you. Is it voyeurism? Should it come under data privacy then? I think these are the questions and contour of the discussion I would like to take the topic with my expert panel here. And to start with, I will request Lakshmi Narayan Rao, I think, to start with his presentation. I think he has an interesting video to show.
Absolutely, thanks. You covered everything. There's nothing much left for us to say.
I just listed the topics.
Thank you. Okay, let's start with the video. I've got a video that kind of actually, brings in the value proposition of AI at the edge, and then maybe it'll take the debate further in terms of really how it is shaping up. Network versus compute, I think that debate is just started. Let's actually get into a full-blown war here. Yep. Okay, can I have the video played, please? If you're wondering why is it that we brought sports technology out here, this race is a landmark race. It's actually called as the race of human endurance because you got actually cyclists cycling over many days, and actually hours where even breathing is difficult. And it's gone through a metamorphosis in terms of the viewing experience. The viewership has actually surged significantly and all underlined because of IoT, because of technology. The reason why we talked about it, why I brought up this video is to talk about capabilities today. When we talk about edge, that's the extreme edge, where you got connectivity actually provided through choppers that are following the cyclist. Look at it actually from all aspects, from not only just the viewer experience, from the safety of the cyclist and also predictable stuff. This is really what we call as the ultimate test of human endurance, and the technology is really an endurance test when it comes to what you can do with edge. I think, I'd like to touch upon one of the aspects, which was brought up by IVK in his initial discussion. I think this whole debate about, network versus computer, very interesting stuff. But when you really look at what's happening in the world today, I think edge is being talked about in many, many respects, and edge is actually really taking the buzz. Why so? Two important reasons. Edge is really where you're acquiring all of the information, and IoT has really been there. I think we reached a level of maturity when it comes to IoT. Then again, the question is, what do we do really with acquiring all of the data? If you look at edge and the way it's actually metamorphosing today, is not just about acquiring the data, it's also about actually filtering the data that goes eventually into machine learning algorithms that are in the cloud, and also, for response time. Latency is not the only reason, although it would actually help a great deal for specific use cases that your latency is actually down from 5 seconds to 0.5 seconds. The jury is still out on whether it's actually the network that wins or the compute that wins, but I would like to actually, start saying that, look at 5G. There's a lot that is being made out of 5G, and there's a fair bit of, edge in 5G. There's a little bit of a dichotomy out there, isn't it? Because we are building network speeds to whatever levels in 5G, then what's the need of actually processing everything at the edge? But ironically enough, actually edge cloud is being driven by the network providers. So you'll see this battle actually pan out significantly, and the IT industry is actually fueling this entire adoption to the edge computing in a big way. Look at really what's happening, and I would like to actually stop after saying this thing. The first thing, if you really look at GPU, the processing ability, AI is actually because of GPU, one can dare say this. And most cloud providers have started offering GPU as a service. Look at GCP, look at Ali. All of them have started offering GPU as a service, which technically means processing capability is immensely there. Your machine learning algorithms are now able to actually, harness the immense potential that is there thanks to the GPU. Second part of it is, if you really look at, the processors, they are really becoming, stronger and smarter, but they're not at the edge. But look at what NVIDIA is doing. NVIDIA, with its Jetson, is actually putting an enormous amount of capability right there at the edge. And then you pair it out with what Google is actually doing with the TensorFlow. There's TensorEdge. For those of you who are watching this space closely, TensorEdge was announced recently, which actually brings in that element of processing right there at the edge. And then you have filtered information going back into the cloud to create a story that's a very compelling machine learning algorithm stuff. Now, if you look at who is really driving this discussion towards the edge, it's actually the telcos. The network is no longer a dumb pipe, and we can continue to debate about it, but IT is actually fueling the whole edge cloud as a concept. Ivik, I would like to stop here and then come back later for a discussion on any other topic that will come up with the panelists.
We'll go in a round-robin fashion. With Danilo now with opening remarks.
Yeah, can I show a few slides? So, following the presentation I had today, let me quickly connect. I don't need the audio. No, it's okay. Yeah. That's this one. So, following the presentation I had today, the key messages. You remember the question, trend or technology similarity? When I started a few years ago on the subject, it was a fun story. I was working on computer vision. At that time, computer vision, back to 2012, it was based on handcrafted methods, okay? And I went in China, and I met one of the top service provider there, Alibaba. And one engineer, for what it represents, the words of one engineer, said, Danilo, if you are trying to push machine learning on the edge, you are totally wrong. And why? I mean, he destroyed in a second the work I've done in months, if not years. And why? He said, simply, I have unlimited resources. Should I need x86, I can have as many as I like. Should I need GPUs? Unlimited. Should I need a memory, power consumption, unlimited? There is no limit, no cap in the capability to build whatever cloud is needed. Well, I think he was seriously saying the true things, but that is only one side of the story, because if we are used to consume what we have without thinking about what we have, maybe the optimal point is not there. And as a researcher, my job is to find if there are better ways to do the things. And as a researcher in an industry, obviously, to transfer such solutions in company products. But if you forget for a while the STM32 microcontroller, this guy was wrong. Because imagine a day where, for some singularities, those unlimited resources will not be anymore available, okay? So we need to find another computing paradigm, and is not the computing paradigm, the right computing paradigm based on GPUs. Because GPUs are for graphics, not for artificial intelligence. I'm sorry for NVIDIA. And I worked on graphics for years, especially I saw the rise of embedded graphics in mobile phones with Nokia, where graphics was not there. And these are a totally different beast. So we need seriously to rethink how we do the things. But as you saw in my presentation, the tiny intelligence is already there, and I demonstrated this week with Gaia in another example. Is just an example for a day? No, because the tiny intelligence is here to stay at the edge. Being ST or another competitor, it doesn't matter. The need is clear. The point also is about, have I enough computing power to run AI? Well, that's not the point of having a simple microprocessor or a huge hardware accelerator. The point is the sensor rate. If the sensor rate for certain use cases is quite low, then maybe a software solution is fair enough. If the data rate from the sensor is high enough, then maybe the processor in software is not enough, and I need hardware acceleration, but I need ultra-low power acceleration, not watt acceleration. I would say microwatt power consumption for the hardware acceleration. These are the key challenges that we have in front of us, not to apply another GPU at the edge, because it doesn't make sense. Examples, the methodology I shown for supervised learning, but you can see applied on different type of sensor, images for food classification. You may say, Danilo, this is not 4K 60 frames per second. That's right. But what is real time? Real time is decided by an application. So if I want to put my camera in the oven to check if my food is cooked enough, I don't need 4K, I don't need 60 frames per second. I can check from time to time the level of cooking of the food. Or maybe to enable speech recognition, very huge speech recognition, maybe I need some triggers. And the trigger can be based on AI, on a tiny microcontroller, for example, for small sentences or for keywords. And the other, for Industry 4.0, for example, we put this tiny board that I shown today close to train wheels. Why? That was demonstrated at Electronica 18 with a partner. Why? Because by monitoring the vibration of the bearings of the train wheels, we can make the journey experience safer. So the train will be safe because the bearings are frequently monitored in their aging. There is also an unwanted effect, which is very nice to notice. If I sensorize the train wheels, the train itself becomes a sensor. What does it mean? I'm sensing, monitoring continuously the railway from time to time. And that is quite important because maintenance happens. So the train will check the maintenance applied to and the status of the railways. For smart cities, for example, with another partner, we did car counting. So by exploiting the Doppler effect of the sound emitted by cars approaching or leaving the microphone, you can count them. And maybe in the future you can also recognize the type of cars. So these are the type of applications, just a few examples, enabled by our methodology, obviously by chance with our tool and our microcontroller. But those applications suggest that Edge AI is totally feasible with cheap hardware, and here is once again here to stay. Thank you.
Good afternoon. So basically, we work on two areas. So I'll give two examples where we are working. So these are underprivileged edge devices. And there's another application which is on logistics, which is ultra, underprivileged in the sense that, I'll talk about the smart metering application. So a lot of assumption on AI or ML is that, the data goes seamlessly to the cloud. Whereas in practice, we have seen, the data from the end node doesn't really, goes to the cloud as we seem. So, just to give the examples, in the coming days, India is, 300 million smart meters market. And the current data, network uptime from the cellular systems is around 60 to 70%. Whereas, the global standards or SLAs demand 95% because this is critical IoT. So from cellular world, you move to mesh or, other RF topologies, or there can be mix of both of these. And more specifically, we have a demonstrated use case where 30 million smart meters are already running on RF mesh. So when you start deploying these systems on the field, you have end nodes which are, sending data to the other device sending, to the gateway which has to manage its topology, and two gateways talking to each other, and then finally aggregating and sending it to the cloud. And in between, you have, transformers, the load balancing, and the smart grid concepts which you have to manage. And it has to be extremely low cost. So which means, if you're talking about 300 million smart meters, and if each meter were to cost $100 each, so we're talking about $30 billion worth investment over here. And worldwide, 1.7 to 1.3 billion smart meters have to be replaced in coming years. So you can imagine. So we're not talking about the metering as such. The meter is a meter based on standards, but the communication and the data flow from here to cloud, and how much you do, even to manage the data on the cloud is where I think edge computing is very relevant and important. So that is one. The other application, Lux gave a good example of Tour de France. So we are talking about logistics market where, we have to manage pallets, containers which are not powered. So which means they have to run on extremely low power and sending, 12 bytes of data, few times a day, and maybe receiving 8 bytes of configuration data. So that's how you, maximize 10 years life. So in such systems, they have to be capable of sensing their environment and, packing as much information as possible in those 12 bytes so that, I can then run deep learning algorithms on the cloud side. So I think we have to sort the fundamentals first, and between, the edge device and the gateways in between, and, all the pieces which take up. So there'll be, a good mix of things which you can do at the edge versus what you can do on the cloud.
Okay. Good afternoon, everyone. Of course, so being last one on the panel, probably most of the things are already covered. Try to see what best we could see. It's working. Thank you. Okay. So to start with, right, I think at the beginning of the discussion, I think IVK spoke about the battle is on. I really don't see that as a battle in terms of, like, are we actually moving towards edge, or like, is it something that needs to be achieved? If you really look at how the compute paradigm is actually shifting, right? Back in 1970s, so we had all mainframes, right? So pretty much all the workload done on single place, and then like you have terminals doing every job, right? Move back 20 years from 1970s, 1990s, we moved entirely to PCs, right? Micro PCs and then desktop PCs. Large chunk of your workloads, your CRM management, your HRM management, much of your analysis, the entire Salesforce was actually done on a desktop PC. Things were working, right? And then again, move 15 years forward, we actually start seeing where the cloud came up, right? I mean, the internet became very popular. Google became very popular. It says all the workloads can actually push on the cloud, right? Say like one common place, the infinite compute and storage and other resources, you could do everything there, right? So now, from there, 10 years, right, we are talking about edge. So if you really see the timeline also, we are moving from 20 years, 15 years, and 10 years. We're shifting, right? The compute model actually keeps flipping is what I strongly believe, right? There's no battle to be won in terms of edge versus otherwise. It's only in terms of way we want to process the data, what kind of application we want to run, and on that duration of time, what kind of resources and economy does the system provide, right? So back in 70s, yes, the economy was pretty much needed for centralized operations, right? Then Moore's law kicks in, like you're going to have microcomputers, you're going to have PCs, things change. And from there, people really figured out when the internet explosion happened, like you have a lot more data than what you could probably process on your PCs. From there, you move towards essentially cloud, and then again, like you're seeing the compute is actually increasing much faster pace now. From there, you move towards edge. So it's basically just flipping between distributed versus centralized architecture. That's all I'm actually seeing. Right? Okay. So now second question was more in terms of, okay, so what do you want to learn? I mean, if you say you're going to have edge, I think Danilo talked about, we already have a tiny intelligence system down there. What do you want to run in the edge? It doesn't make sense. And of course, we also talk in terms of if I'm going to have a lot of the smart meters, most of the data is actually collected on the edge. You do everything on the cloud, right? So it essentially becomes a combination, right? A combination. By the way, this is a picture which I got from one of the recent IEEE transaction. So what it really talks about is when we are actually having a lot more data to be processed, right? A compute paradigm wherein you actually have a learning layer in the central location. That's what is probably the cloud, right? So you have a high-level deep neural network layer, higher number. The complete learning is happening there. The models are actually created on the cloud. And subsequently, right, you push those models to the edge, right, where you got to worry about latencies, you got to worry about fast response, and then you actually do the inference on the edge. That's a model which probably things work if you're talking about how we could really see the ML and AI would work on the edge, right? Now how does the application itself looks like when we move away from cloud to edge, right? If you look at it, the conventional cloud, I would say, was predominantly taken over by what I call Maggie. That's basically Microsoft, Amazon, Google, and IBM, right? That's where they had everything, right? So you basically had all the applications predominantly developed by them, the hardware by them, the management by them, everything is done by the Maggie, right? Move from there to what you could really call it as a edge computing. what we really see is a complete democratization of the applications, right? Now, we don't have one single person who's actually forcing you to tell that what kind of database you need to use or what kind of learning engine you have to use. It's going to be completely democratized based on what needs somebody wants to develop, what kind of application people want to develop, and based on that, you're going to have multiple applications coming up. And subsequently, even the hardware, in my opinion, is going to be pretty much commoditized. You don't need a super hardware from what probably the Amazon and Googles are giving. You're going to have almost very similar capabilities, if not same, very similar capabilities being pushed down to the edge by, be it Jetson board or be it even a simple Raspberry Pi, right? I mean, Raspberry Pi with a TPU attached over a serial interface could also provide you enough compute for you to do most of the inference and model inference at the edge. That's something which is possible. And this is a kind of model which would probably work down the line. And what's actually opens up to this is basically the intermediate layer wherein you could probably create a common framework for the applications to come and sit on top of it and then run on independent or commoditized hardware is where we're going to see some real actions there. Sorry. Right? So what's really cooking up in terms of, we're actually seeing significant ecosystem development. Somebody like Linux Foundation is actually taking up additional projects, like these were the two new projects which came up with the Linux Foundation, to really say how you could, I talked about the middle layer in the edge, and these are people who are actually helping to mobilize this middle layer for people to create applications and then use commoditized hardware to run your solutions, right? That's what we are seeing. And of course, we're seeing a lot many new stealth mode startups coming out in this particular domain. And I think one of the things which actually would be very, very challenging in my opinion, because I'm actually taking to the next step telling that, so we are no more talking about a battle here, so we know how AI/ML need to be done on the edge, and then you no more need to work on a proprietary hardware, you're going to run it on a very, very commoditized hardware. What is the real challenging stuff that's actually going to be there is basically the complete integration. You might have to think of integrating your edge cloud. These are like the models which people talk about in terms of how you probably integrate two edge sites and then how the data share can happen over there, what kind of model share can happen over there. That's the biggest challenge which I see that's out there. Okay, thank you.
Since we heard their opening remarks and their perspectives on this topic, I do have a few questions across many of these categories to go into a little more depth. I do know that some of you are deeply technical and some of you are barely technical. So I don't want to make it so much tech that it will just bore you. At the same time, not too shallow that there is no insight. But picking the point where Chetan left at, I do have one question to, I think, Chetan and Danilo first. But before that, let me just explain for those people who are not familiar with this edge computing models. I find there are three distinct perspectives which are normally either in conflict or in convergence. The classical cellular network guys think that you do everything close to the device because you have to enable support for latency, for battery management, heterogeneity, and roaming, right? Mobility. The datacom, the erstwhile datacom people who moved to cloud or network-based cloud computing models who are more on the network side believe that they should push analytics to the edge and not everything to the cloud, so maybe offload a part of it. Then we have the extreme other end, who are typically the actual compute guys, who think that it is basically data center being pushed to the edge or to the device layer or close to the device layer. Now, from a very different discipline, I used to work in electronic warfare. If you go to intelligence systems in India or abroad, the intelligence in general, normally intelligence is generally made central, right? You acquire in the field, but you analyze centrally, right? But you act at local. So this is the classical model why you try to close the loop. So my question, if I'm a startup in Edge AI ML model, my question to Danilo and Chetan is, Amit, my question to you is, in terms of, since you offer many services and solutions to IoT, in IoT area, is there a difference between a solution which is standard, which you can offer like a SaaS model, versus a very custom solution? So if I go back to the old IT services model, most of them were custom. But in today's world, in your experience, are they more standardized or which can offer like SaaS, or is it like more custom?
So this is, the question which we also internally debate, which path to take on. I'm talking here about the asset tracking and logistics market. So, last week we were in a global partner meet on Sigfox, and we had a cattle tracker, right? Ideally, we would, and we have end-to-end, we have platform, but then you meet customers from Ghana, Nairobi, somebody is tracking cows, somebody wants, for somebody cat is important, and the collar size and the requirements are very different. So, it's not like the earlier times when, mobile or set-top box, they were like mainstream, what kind of chips, what kind of capabilities you are. Here, IoT, apart from, few critical applications like, metering, is very, each country, each specific use case will need customization. So your competitors will be your partners in some sense because you can't, cater to all these, even the end devices you can't do. So you have to have a mechanism where, you can ingest a lot of data securely and then have a common view of, the analytics which you can offer to your customer.
Just as a follow-up question, do you see a difference between an Indian customer versus a global customer when it comes to edge computing?
So I'll take, the smart metering case over here in India is very cost, very cost conscious, where, so just to give an example or comparison, a smart meter in US will cost around $100, $120, whereas in India we're talking about $40. So which means, and Indian meters, $40 includes the cost of corruption in the sense that you have to detect, all the tampers and misuse, mishandling done by so you have to detect. So there's $5 to $10 in that $40, which is specifically for that. And on top of that, you need to manage your loads so that your transformers don't burn. So that is a capex. So I think, managing all this in India, there's another dimension of cost which comes into the picture. Whereas in the global scenario, the utilities are more about standards and, the SLAs which are more reasonable, and scalable.
In your experience, since you deal with many customers and across many areas, this is a question on talent. Do you think that the analytical skills on the cloud are portable to edge? So I have somebody who runs analytics engine or analytics code on cloud. Can I just use the same person on edge?
So, Danilo partially answered. We worked in the same team earlier, and we were handcrafting hardware to software, doing the video algorithms, 25 frames per second, full HD frames. So that's a lot of computing. So principles remain the same, but then he also explained in his previous show, you need to scale those algorithms. So as it is, it won't be applicable. Maybe you'll need to use lookup tables or pre-compute those values because, at the end of the day, what am I tracking? A pallet which costs $25, $30, your end node cannot be more than $5. So in $5, you can do only this much. So which means, your models have to be quantized, even if they, are erroneous. So it's still better than sending, accelerometer data back to the cloud versus saying that, okay, there's a motion, there's high impact, there's a tilt. So you classify on the edge as much as you can, even if it is wrong.
So Chetan, since you run a startup, I will push the same question on talent in a slightly different way. In my view, and in whatever I have seen in AI ML across, including IoT, typically you have one type of skill sets which the talent pipeline normally belongs to is statistical, who run regressions, etc. Right? They come from statistics background or mathematics background and know how to run statistical models. Then there are other set of people who typically come from computer science, and they understand text mining, linguistic analysis, etc. Then in case of IoT, we have to add the signal processing, which typically comes from electronics communication or electrical engineering background or media processing backgrounds, who understand, fast Fourier, discrete cosine, stuff like that, right? Maybe they're also firmware aware or chip aware or architecture aware. Now, the trouble is that for most people today, when they say they know something, they actually know Python and its package, right? They don't have to know what is logistic regression. I just need to know I have to use it. Same thing for TensorFlow, right? I just have to submit to TensorFlow. I'll get the result back. Now, so for most people, knowledge is same as skill sets. So if I take a Python, or there's hardly any R now, everybody uses only Python packages. So Python, let's assume, or scikit-learn, whatever you want to say, which are classical analytic skills available widely today in the market. It's like PHP at one time, right? You chose PHP over Ruby on Rails because I can get people in PHP. Now, if I put them on the edge, are you saying that in your team, you are going to have somebody who knows analytics in general, the people who know signal processing who can now fire a fast Fourier, and people who know a little bit of topology of sensor networks, graph theory kind of thing? Are you saying there'll be three distinct skill sets in the overall realm of edge computing?
I mean, skill set is one part of it, but if you're talking about, am I going to have three distinct people to work in my startup, then I can't run my startup, for sure. Yeah, I think you put across very well, right? I think the statement which you made, wherein people thinking the knowledge as skill set, like that's something which we definitely see that. So because, as you rightly asked, the kind of people whom we interact with, like especially like on the hiring front, like I mean, we do get people who probably are very good on Scikit and Python and a little bit on R, and they don't even know the basics of log regressions or any of those things. Like, we do see those kind of things, right? But in terms of, I mean, okay. I mean, one is of course, since as we are a startup, like I mean, we run very lean and mean. Like, in which case, I can hardly hire one person in 4 months to 6 months. I mean, that's the best I could do. So in which case, I have a lot of lead time to do the interview. That's one thing. So we look at least somebody who really going to be very strong in terms of understanding the concept. Gone are the days wherein, like, I can hire somebody who with a specific skill set or specific knowledge, like somebody knows Python, somebody knows R, and like he can come and work on a system. That's something which is really not possible, right? So what we really need is somebody who can solve a problem, right? And that's the kind of thing which we need with a specific background on somebody who understands either on the data analytics, that's what you call in terms of statistics, or on machine learning part of it. So we look out for somebody who has really the knowledge rather than he just had a skill set. He knows a language, he knows a tool. That's not what we really look for. Somebody who really understands what it is. And in terms of, do we put three different people? Obviously not. I won't look at one person who probably has knowledge of all these things. That's the best we could do.
So as a follow-up comment and a question as well. So this is regarding data. So now that you answered the other side. So in many of the analytics startups, with almost everyone claims AI, ML, blockchain, or whatever, but most of the work or most of the effort goes in basically data management, right? Ingestion, curation before your algos fire, right? Now, if I apply that into edge computing here, aggregation of data or cleansing or curating, is that skill set same from the cloud angle or a server angle? I mean, anyone.
Yeah, I mean, I feel it's almost same, like in terms of what somebody should understand, what's the meaning of cleansing the data, and what somebody should understand how much I probably want to cleanse the data. That's remains same. But things that are going to be different is in terms of resource availability. So you can't probably run a single loop forever and then see what's going on in the system, right? You're running a hard system over there, like you're running an embedded system, running a gateway device. So the activity remains same, the skill set remains same, but then somebody implementing that is going to be different. That's how I look at it.
I think, we need to have a skill set where, we have a very thorough understanding of what kind of hardware and what kind of instruction set is available to us. That is very important so that you can derive, maximum juice from your hardware. And then, depending on what you can implement there, then you segregate your compute, whether, what is possible. And what is possible is also defined by the customer, how much is he willing to spend for his particular use case on that device. So it starts from, bottoms up rather than, I have this algorithm, I want to push it on you. So it's not, so I would say it's bottoms up. Customer defines, I have this much money to spend and give me what best you can give.
Yeah, from my perspective, the time where we have specialists in a team is over. In the sense that it doesn't matter if you are a startup or a small research team, the challenges are the same, innovate. And in that respect, we need people that have got multiple type of knowledges. Maybe more specialized in one aspect or in the other, but for example, Python is something which is very, very far from hardware aspects. However, without a knowledge of Python, today, data science and AI cannot be made. So we need to master not only the hardware design, but also high-level programming, such as Python, and create the bridge. I would like also to say another thing, that we need at least few key guys that are able to fly very high. It doesn't matter if it is a startup or a company. People that are able to understand at high level the problem, abstracted enough from the details, that have a global view of the challenges. For example, another point I would like to mention, in my presentation I was speaking about that privacy is gone. That's true, because for supervised learning, it's almost 20 years that we give for free our data, and they are gone. So our privacy doesn't exist. You accept or not, your data are already available to the major what you do. And so that's not the problem. And this suggests a challenge, sovereignty of the data. So, which means that if I get the temperature in my house, who is the owner of this data? Is myself. If I share the data in India, it's the global country that has the sovereignty on this data. So we should also to look at this aspect more carefully, because that's really region dependent.
I have one question which is a little more conceptual, but for those people who worked in late 80s and early 90s in communication systems, especially Datacom, there used to be a very famous statement: switch when you can, route when you must. That was the paradigm for most of the design. Taking that statement, what will it be for edge computing?
I'll just make an attempt. So probably like, because especially this Datacom statement is very popular, because sort of been there for a long time. We just know that, right? So probably like in case of edge computing, what I would say is like your switching is actually edge computing, and putting it back onto the cloud is actually routing. That's how I look at it, right? So you want to do things faster, you want to do things locally, so go ahead, do switching, go ahead, do edge computing, right? So now, obviously, you cannot do switching unless there is something on the top to tell you where you want to switch the package to, right? So obviously, you cannot create an inference model on the edge unless somebody does the learning on the top in the cloud, aggregating your data from multiple edge computing sites, right? So one of the the model which people talk about is you get data from multiple edge computing sites, develop your core learning algorithm, define new models, refine the models, and then keep pushing it onto the edge, right? So now this defining model, refining model, all those things is routing for me, right? Which is to be done in a very slow path, or rather routing is not in slow path, but to an extent, right, wherein like you probably do there. And then when actual your data comes in, like your video feed comes in, or your high throughput industrial data sensor comes in, do the processing locally on the edge. So basically we're working with one of our customers, like they generate like almost 2 GB of data per hour, right? 2 GB of data per hour, taking that, pushing it to the cloud and processing it over there and taking an action based on that and come back, decide whether this particular oil mill needs to be changed or whatever it is. Like, that's not going to work, right? Like you need to do the things on the edge, and that's switching for you. And how do you define this model? Where have you learned the refining of the model? That's in the cloud. That's your routing.
I agree with the,
In my analysis of IoT startups, I find two distinct approaches. This is purely from business and investment perspective. People who believe that we need to run on our custom hardware with our software to get the best performance. And the other set of people who say that let me use commodity hardware, let me just show the difference in software. Now, if I'm an investor versus I'm a customer, so I'm trying to show a slight difference. If I'm an investor, I will say that at scale, you won't be able to do your own hardware. So give me a solution which is only software and let somebody else figure out the hardware. Whereas on a customer side also, we believe that at scale, most customers will say that a startup cannot really handle its own hardware. It will end up flipping to a commodity hardware or their own hardware. In fact, we have seen cases where they say, you replace your board with my board, but give me your software. Now, where do you see this going?
If I comment. I go back to the sovereignty of data, because everything starts from here, data. And who owns the data? So, I mean, in India, I'm not sure how you are managing your rights on the data. That's very important. From the data starts AI. From AI starts the software that may or not may be efficient on the hardware, but in some cases yes, in other cases no, and may push for specialized hardware or to use standard hardware as I suggested. So if we start to change and see the problem in that respect, then huge opportunity arise. Otherwise, AI is already gone because, and is already in the hand of the few major internet companies around the world. But that's true because, back to the initial statement, we are not aware or we sacrificed so far our sovereignty of the data, which is the starting point.
Danilo, in case of in utilities, I can take the example. They're in India, the data stays with the utility, stays within the boundary, so they're very protective in that sense. So is the case with healthcare. So those are applications at scale. But I think the question was, how do you, how the VCs address, whether an IoT company is hardware-centric, should we put money on that versus software? So I think we need to emphasize over here that IoT is not software alone. There is a significant hardware play on that, and that is what, that is the physical thing which customer buys. And that has to be there, and then you can sassify it by saying that, okay, I'll serve you for 7 years, including my software cost and all. So those are the business models which have to be discovered, but you cannot wish away hardware for somebody else, because who is somebody else in critical IoT? Somebody else will be somebody from China or somebody from, so there are security implications on that. So you have to take the complete ownership of taking the data from the smart meter or your endpoint to the cloud, and then, it's up to the utility how it, or any customer how he, chooses to analyze his data. But the core responsibility of taking the data from the end node to the cloud is one entity, not two separate things.
As a quick follow-up question,
Yes, I'm sorry.
Yeah, sure.
Yeah, just one thing which I want to add here. I mean, probably maybe controversial also. I mean, I don't know. See, basically, like, why would somebody want to have a customized hardware? Right? Why would somebody want to have proprietary hardware, right? So it's completely business driven, because I used to work for companies wherein like you get a RAM, 4 GB RAM, you get it outside, and that's going to cost you like whatever, $40, and then like, I mean, you buy the same 4 GB RAM, which can fit into, I mean, it's the same RAM, like I don't see anything different, but it fit into your equipment, it's going to be $200. I mean, the difference is like, you're actually you're actually making a customized hardware only because you want to actually figure out how to make the additional money, or to some extent even because you could actually create a much small footprint hardware, much lower price than a commoditized hardware, what you get outside, right? That's how things used to be. Now, I would say we actually moved away from that. You get a general purpose processor-based system with a TPU almost at a price what you could get when you make your customized hardware, right? Now, once you're actually getting in there, like you go use the commodity hardware and then show the differentiation in the software. That's where things make a lot of difference. Gone are the days wherein like, I need to have my customized hardware, only then I can probably make the cost lower. That's no more is what I feel.
So I'll leave just a thought with you, it's not a question, but this is exactly how the data center designs went, right? So the moment the PUE number drops, you will run custom hardware and not COTS hardware. So if you have billions of devices connecting, why will it not work for edge computing? Same argument. But anyway, I have a related question in a customer context. If you take an analytics firm, AI, ML included, at some point they have to make up their mind how deep and high touch they want to go into a particular enterprise context, or how light touch they want to go and horizontally scale, right? In edge computing models here, how deep is the integration in a customer context? I mean, do I need to do other things in terms of connectors, integrations, in which case I broaden my pie, or how does it work? Is it a federated system, or is it just a vendor model where somebody else will manage the overall view? In fact, the follow-on question on that is on data, because when you aggregate data and you give it to an enterprise, from GDPR angle, who is the data controller? And if you say the customer is the data controller, then I have to ask you the question, how do you retire the data and who does it? Because it's machine data, right? But I can derive a lot of user context from your machine data. So limitation of scope, data retiring models, and the role of data controller versus processor, how does it work if you have such a deeper integration in an enterprise?
So I'll take the example of, I didn't mention this, but we started some work in telehealth, and we were doing remote patient monitoring, ECG monitoring. So on the edge side, you are detecting, immediate alerts, it's right here, and you are able to detect some arrhythmias. Then few things you analyze on the cloud, and, you get an update. A bigger system is, looking at data at the national level. Why is some customers with this BP, these values, this ECG pattern are still healthy, whereas in the other they are dying. So there are layers after layers, and the data owner can be, government at the highest level, where they want to analyze what is happening in our country, and it can be at WHO level, where they are analyzing, which race is susceptible to which kind of disease. So I think
Evolving.
it's quite involved, actually.
Maybe we
Yeah,
take a, yeah.
in term of integration, the situation is quite massively fragmented. If I see from the angle of edge computing, of fog computing, and it's not easy to be managed. But there is a common denominator, which is the interoperability. So whatever is the type of integration, vertical, horizontal, or massively fragmented between the different actors, the common need is interoperability. Now, there are no standards around AI that are significant at the moment. There are some attempts from ISO for neural network representation. Other are de facto standard by who develop deep learning tools. So, but that's definitely a need. Otherwise, we computing close to the sensor, but if it's not able to interoperate, then the problems start to arise.
At this point, we'll pause here and then open to audience Q&A.
Good afternoon, sir. Sir, question is related to the beliefs in India. There is a particular day when around 300 million people, around 3 crore, more than 3 crore people visit a city which is approximately 1/9 size of Bangalore, 84 square kilometer city known as Prayagraj in northern province of India. More than 3 crore people, 300 million people visit in a day. And UP police, Uttar Pradesh police, they want to do analytics. They were doing some pattern matching to find some mischievous activities from those 300 million people, those visit on a auspicious day of Moni Amavasya. Sir, in that case, what do you think, edge AI will work or cloud computing?
I just want to start with this, right? I mean, I had actually given this some of the presentation. So do you know what's the amount of data a camera generates, a standard HD camera? I mean, obviously you want to actually capture a mischievous behavior, so you probably want to, and based on the area you want to cover, you don't want to put too many cameras every 10 feet, like probably you're putting a lesser number of camera. Keep in mind, like you're going to have an HD camera, and how much data an HD camera can generate, and assuming like you're probably going to have hundreds of these HD camera. So we are talking about terabytes and picobytes of data being generated just by the camera. And now all this image is captured and send it to the cloud, and you do an analysis, do a pattern matching, and then come back and tell, okay, something wrong happened, right? Economically, this is simply not viable. Pushing picobytes of data into the cloud is not viable, right? So the only option is you want to process all of them, the place where the data is generated, where the camera is getting the data, you do the processing, you do all kind of pattern matching, whatever new mechanisms you want to do, everything over there, and then only, for example, alerts can be sent out. Okay, this particular thing, this particular misbehavior happened in this location during this time. Alert the police and let them come on and do whatever required. So if you look at in terms of purely from economical viability point of view, it's simply you need to process the data on the location, which essentially is edge.
So, just to add on, so I was on that day in Prayagraj. So basically, one of the major use case for monitoring on the camera was crowd management. And, these things are best done on the camera, at the edge itself, where they were basically counting how many people are, crossing this bridge, how many people are in this camp, and then, coordinating on the wireless. So that is essentially, and then you record the feed so that, in case you want to match some Osama bin Laden was there or not, that is post-processing. But at the edge, it was more about crowd management, nothing else.
If I may comment, you may certainly understood from me that I am pushing intelligence as a distributed topic. Now, what does it mean to distribute intelligence? Intelligence by itself means capability to learn. So we need to definitely to think, to start to consider, to learn at the edge directly in order to decrease the pressure on the data, work with less data, provide events, anomalies, quickly, as quick as possible, locally. But if we think that learning at the edge means to transpose what happens on the cloud, maybe we are totally wrong. So we need to rethink what does it mean to learn at the edge in order to decrease the pressure on the data, which means amount of data and labeling of the data, which are the current challenges of supervised learning, in whichever way supervised learning is implemented.
During the panel discussion, one observation I had was the discussion was more on individual systems. I didn't see the topic goes to an integrated system. For example, an accident happens in a highway. What should you do? The traffic management of the city. You cannot do it in edge, am I right? You need to do it in the cloud. Instead of talking about where you need to have intelligence, the discussion should be around what decision you want to make, am I right? End of the day, whatever we do, either you do it in edge or you do it in the cloud, it needs to result in a decision. The decision may be yes, no, maybe whatever it is, but the decision needs to be made. Why can't we talk about some example where there are things which needs to be done edge, but there are certain things which we need to do in the cloud in real time. For example, traffic management is a very classic case, am I right? Even if I delay 1 minute or even few seconds of not switching the traffic light can become miles-long traffic jam, am I right? So how you are positioning that? Why can't we discuss about integrated systems, not at the individual devices? Because throughout the discussion, I felt it was discussed at the individual device level, not as an integrated system. You can treat it as a feedback or a question, but we need to think about an integrated system. Sure. Then you will have more clarity on where you want to do what.
Sure. No, when
I just want to highlight one more aspect. If you consider preventive aspects, if there is a pedestrian crossing a autonomously driven car, then rather than thinking of cloud, the intelligence should be on the autonomously driven vehicle. Thank
you. I understand the individual device level, why we need to have intelligence in the edge. No problem, actually. It can be a collection of small set of devices. I understand that scenario. But all these connected devices is required to run a more intelligent system, overall system, am I right? It cannot be done individually at the edge. It needs to be done overall, and it needs to be done real time. So how we are going to handle that?
Maybe I'll take the example of smart grid over here. So, the power outage happens. So this has to be, so there's something called last gasp, which you have to send within 30 milliseconds to the, the grid or the transformer where he does the load balancing. So that, in the critical areas like hospitals or, there's no power shortage. So that has to be done on the edge. Whereas, the concept of smart metering came because there are a lot of T&D losses, 12% in India, whereas the global standard is 4%. So you need to analyze more deeply where your leakage is happening. So those are the things you compute on the cloud, and the demand response, how much power should you buy from the national grid. So these are the long-term things which you need to predict, a utility has to predict to be able to buy that much power from the national grid. So I think it's fully integrated end-to-end in that sense.
I think we almost run out of time. I just have a closing comment to make. As system of systems model says, again, one more design principle, that the optimum of the sum should exceed the sum of the optimum, which is a very insightful and reflective statement to make on these designs, but that's for another day. Thank you very much, and I thank my panelists, and thank you, audience.
Thank you. Thank you.